Good day, everyone. Today we are talking about section 7.1, graph quadratics in standard form. Our learning targets for today: I can calculate and label the axis of symmetry and the vertex of a quadratic equation. I can identify the minimum or maximum value of a quadratic equation. And most importantly, I can graph a quadratic equation that is in standard form. So first we're going to start with the term a parabola. A parabola is just the name for the graph of a quadratic. All right, so we're going to say it has this U shape to it. And as you can tell by looking over in the margin here, there are some examples. So looking here, the St. Louis Arch. If you were to trace this, so you trace it and you pull it over, there's an example of a parabola. So the St. Louis Arch is another one. For those of you that are big McDonald's fans, two arches or two parabolas. If you were to slow motion bouncing a tennis ball like across the floor, you can see here in slow motion that it forms that arc shape that we call a parabola. Suspension bridges. We'll talk a word problem about the Mackinac Island Bridge, the Golden Gate Bridge, a suspension bridge that uses those cables that forms a parabola. Headlights. The inner shell is a curved arc shape. It's actually a parabola. All right, when we talk about standard form, y equals ax squared plus bx plus c, where a, b, and c are what we call the coefficients. So when we have this equation here, identify a, b, and c. A is the number always in front of the x squared. B is the value in front of the x, we call it the linear term, and c is the constant at the end. So we would say that a equals 4, b equals 8, and c equals 3. Now, some other terms and the things that are going to come up. So first, when we're talking about a parabola, it opens up. We talked about this back in chapter 3 with absolute value graphs. And when we had a, h, and k, well, a still drives whether the graph opens up or down. So it opens up if a is positive. So we're going to have a graph that looks something like this. When we do this, we're also going to talk about the vertex, and we'll talk a little bit more about that. But the vertex is that highest or lowest point. When we did the V graphs, it's the point where the sides change from positive to negative slope. When we talk about a parabola, it has a similar idea. It goes from decreasing to increasing, but what we're going to say is where it kind of turns around. So this vertex here is the lowest point, so we call that a minimum. So whenever a is positive, the graph opens up and the vertex is the minimum. Likewise, if a is negative, the graph opens down, which means this point is not the minimum, but the maximum. It is the highest point on that graph. When you will graph these, you will notice that they are symmetrical, which means I could take a scissors and essentially draw a dashed line here in the middle and cut it into half. This is called the axis of symmetry. And so the left side and the right side are mirrors of each other. And so when we want to graph these, we need to find where this axis of symmetry is. And so the axis of symmetry uses the equation x equals negative b over 2a. And you'll notice that the vertex, in this case, this lowest point, is on the axis of symmetry. So when we have a vertex, and when we talk about vertex, it is a coordinate point, so it is x comma y. Here's the math term for it. So there's negative b comma f of negative b over 2a. So negative b over 2a is the x value. So this is the x. This is the y value of the vertex. Now, I'll be honest with you, this f of negative b over 2a is really looks messy. What this means is plug x into your equation and calculate for y. That's what that's mean. So you find the axis of symmetry, that's the x value of your vertex. You take it and plug it into the equation and calculate it and get that y value. Then you write it as an xy coordinate point. All right. One thing that people make a mistake on or commonly mix up. The vertex is a point and it's a coordinate point xy. The min or max value is just the y value. So when we ask to find the minimum or maximum value, you have to find x in order to find y, but the answer is just y. If it asks for the vertex, it wants the coordinate point x comma y. All right, our first set of problems here. State whether the graph opens up or down. Again, we can tell that by looking at A. So that's based on A. Identify if the vertex is a min or max, again based on A, and then find the min or max value. Again, this will be the y value. So this first example, what we're going to do is we're first going to identify that A equals 1, which means since A is positive, the graph opens up, which means, so it's going to look something like this, which means our vertex is going to be the lowest point, or we call the minimum. And you could just write min if you wanted. All right, now it asks us to find our minimum value. Well, in order to do the minimum, you have to find the x value, so the axis of symmetry. So the negative of b, so the negative of negative 6 over 2 times a. And so we get positive 6 over 2, so we get x equals 3. That is our AOS. We need to find the axis of symmetry so that we can plug it into the equation for y to find the minimum value. So our minimum is going to be 3 squared minus 6 times 3 plus 11. Now, you can put this all in your calculator at one go and get 2. That means our minimum value is 2. That's what that answer is saying. What I would like you to do is to identify A, B, A, does it open up or down, for each of the next two, and try calculating the AOS, and then come back and check your answer before you do the Y part. All right, so on the middle problem, you should have found that A is negative 1, which means the graph opens down, so the vertex is a maximum. Again, I do negative of B over 2 times A. Again, whenever I'm plugging in values for a variable, in this case B and the A, I'm going to put them in parentheses just to make sure I don't make a sign mistake. So we get negative 8 over negative 2, which is x equals 4. Again, and this is something that'll come up a little bit more when we get to graphing, always need x equals on that AOS. On the last one, so you get A is 2, opens up, minimum, negative of 8 over 2 times 2, so you get negative 8 over 4, which is negative 2. Again, plug 4 into your calculator. So again, you're going y equals the negative of 4 squared. So you're going to square the 4 and then multiply by -1. And you're going to calculate that. Again, just putting it all into your calculator one go is perfectly fine. Your calculator can handle it. Make sure you're using negative keys inside the parentheses, and you should be getting these. If not, make sure you're asking in class. So you should get 19 for the middle one and -7 for the bottom one. All right. Next, we're going to shift gears to graphing. So it says graph y equals -x² plus 4x minus 1. What some people will do is underline and identify A, B, and C. Some people, like, I get it, I don't need to. The process we just went through of finding the axis of symmetry and finding the y value is steps 1 and 2. So axis of symmetry, again, x equals the negative of b over 2 times a. So you get -4 over -2. And again, your answer is x equals, because it is a line, it's that dashed line. So for example, here we get x equals 2. We're going to go over to our graph on x equals, again, vertical line. You're going to draw that and label your axis of symmetry, x equals. Again, you need to label x equals. To find the y value, to find the vertex, you need to find the y value. So we're going to say y equals, and we're going to plug in 2 for x. Again, using parentheses, and then you get y equals 3. Now, as we said on the second slide, the vertex is a coordinate point. It is these 2 points, x equals 2 and y equals 3. Put those together. That's your vertex. And so we're going to go plot 2, 3. Now, when we talk about plotting 2 more points, what we are going to do is actually we're going to make an XY table. And you can make your XY table go horizontally. You can make your XY table go vertically. It's your choice. But always put your vertex first. And then when making an XY table, you're going to just go, okay, I'm at 2, I'm going to go 3, 4. And then you're going to plug in 3 in for that x value into your calculator and calculate it. And when you do, you should get 2. And then when you plug in 4, you should get -1. And so then I'm going to plot 3, 2, and 4, -1. Now, when we do this, we said these graphs are symmetrical. That's why we drew this vertical dashed line. And what it means is for each point on one side, there is a mirror point that is the same distance away. So if I look here, this point is 1 block away from the axis of symmetry. That means there is a point that mirrors it that is 1 block away on the other side. It's going to have the same y value. It has the same height. So all we're doing is basically we're flipping that point across the axis of symmetry to find its mirror point. This bottom one we count is 1, 2, so we're going to count 1, 2. There is the mirror point. When you go to graph these, I recommend starting at the point left of the vertex, or right, but starting at the point left, curving through the vertex, and going through the points on the other side, drawing arrows. Again, starting on the point on the right, trace your line, your parabola. I find that people draw them more accurately. Instead of drawing them straight, they draw a nice curved parabola like you should. And that is walking through the whole process. Now, I get questions all the time. Mr. A, do I have to count up? Couldn't I go 2, 1, 0? And you are correct. You could go to the left, you could go to the right. Because they are mirror points, it doesn't matter. I personally just count up. So I count to the right every time. So I go, oh, I'm at 2, I'm going to go 3, 4. That's personally just how I count, so that's how I do it. All right, I would like you to pause the video and try to do the axis symmetry, vertex, and the XY table on your own, and then I will walk you through the graphing process again. All right, so for number 1, you did negative of b. In this case, b was negative 6. So you did negative of b. So negative 6 over 2 times 1. So you get 6 over 2. You get x equals 3. Draw that vertical dashed line at x equals 3 and label x equals 3. That's your axis of symmetry. We then took 3, plugged it into the equation, put it all in our calculator at one go with parentheses and got 2, which means our vertex is 3, 2. So we plotted 3, 2. Again, to get more points, we make an XY table. We started with our vertex. That's what we got right here. Our vertex was 3, 2. So I said, okay, my next values are 3, 4, 5. Again, as I wrote here in red, you could have gone 3, 2, 1. It doesn't matter as long as you go the same direction. And again, so what we're going to do is you're going to plug this into your calculator. So instead of the 3 in the parentheses, we're going to put 4. Instead of the 5 in parentheses, or instead of the 4, then we do it again with 5 in parentheses. And so we get our XY table. Again, once we have our points, we are now going to plot 4, 3, which I count is 1 away from the axis of symmetry. So we're going to go 1 to the left and plot the mirror point. Then we're going to plot 5, 6. And again, when I'm plotting these points, I'm always starting from the origin. So I'm going over 5 and up 6. I am 2 away from the axis of symmetry, so I'm going to go 2 away on the other side. My last step is to draw the smooth curve. Again, I'm going to start 1 point away from the vertex. So that way I'm going to go down through, up and through my points. Again, start 1 away from the vertex, trace what I did before, curve up and through. And that is graphing a quadratic. So I would like you to pause the video and try doing this one entirely on your own. All right, so you can see here the axis of symmetry was negative 8 over 4 became negative 2. We plugged it in, got negative 7, so our vertex is negative 2, negative 7. Again, I went negative 2, negative 1, 0. You could have gone negative 2, negative 3, negative 4. Either way is fine. You get negative 7, negative 5, and 1. You plot the points and the mirrors. So like I counted that like 0, 1, for example, was 2 away from the axis of symmetry. So that's 2 right. So I go and go 2 left to get the mirror point. And again, I draw the smooth curve. I would like to look at this one just for a moment because this one trips people up. In this case, we are missing the middle term, the linear term, because we could have written it this way, but we don't write the 0. We just don't put that placeholder in there when dealing with polynomials. So the big trick with this one is that b equals 0. So when we go to do our axis of symmetry, we get the negative of 0. Well, 0 divided by anything is just going to be 0. So when your b value is missing, your AOS, well, your b value when it's not there is 0, therefore your AOS will be 0. The nice thing about when I plug in 0 is that this cancels out. And so this is called the y-intercept. And so whenever you plug in 0 to the equation, you're always going to get the point 0, comma c, where c represents your constant at the end, on every single one of these graphs. So as you're going through and calculating, if you can go that you can use 0 as one of your calculation points, I can just look at it and go, oh, if I plug in 0, I'm going to get whatever the c value is. I'd like you to pause the video and finish this. I know when you are doing these on where your axis symmetry is the y-axis that it's hard to see. That's why it's important that we are labeling so that we can see where our axis of symmetry is. And again, you'll notice, unlike when we drew lines, you do not have to extend your parabolas all the way to the edge of the graph. As long as you are doing it past the points using arrows, I'm all good with that. All right, we are going to do a bunch of these in class, so if you have any questions, make sure you are ready to ask. But otherwise, we're going to look at this word problem. The word problems are actually pretty simple. The numbers aren't super simple, but the concept is. So this one says the suspension cables between the two towers of the Mackinac Bridge, or Mackinac Bridge, in Michigan form a parabola that can be modeled by this equation, where x and y are measured in feet. What is the height of the cable at its lowest point? I know it's a little bit hard to see, but if you can kind of trace right here and see this cable from post to post has this parabola shape. And so the lowest point is just finding the minimum. So in other words, it's just asking us to find the y value of the vertex. So do the negative b over 2a to find the x value, your axis of symmetry, and then plug that into the equation to find the y value. So pause the video and go ahead and find the y value of the vertex. Again, so we did the negative b over 2a. I'll be honest, I put this in my calculator at one go with the alpha y equals. So I did negative parenthesis negative 0.37 over and then did 2 parenthesis 0.00097. And that way I don't have to deal with a lot of small numbers and dividing, just do it all at once. I get 1907.2. Plug that back into the equation to find the y value. Again, the problem said to the nearest foot, so it was like 196.2 something. So it would round down to about 196 feet. If you have any questions, make sure you are ready to ask. Otherwise, have a great day, everyone.